BGP is a routing protocol used to exchange routing information between different autonomous systems on the internet. BGP route reflectors, or RR, are used in a large-scale networks to simplify the routing process by reducing the number of iBGP peer connection required between routers in a network. In a traditional iBGP network, all routers in the network must peer with each other to exchange routing information, resulting in a complex and resource-intensive network design. In a BGP RR design, routers are divided in two categories: route reflectors and clients. Route reflectors are special routers that act as a central point of communication for BGP clients, for iBGP clients, eliminating the need for direct peering between all routers in a network. BGP route reflectors design involves several important considerations to ensure optimal network performance and reliability. These include the number of route reflectors, the placement of route reflectors, and the configuration of route reflectors. The number of route reflectors required in a network depends on the size and complexity of the network. In general, it is recommended to have at least 2 route reflectors for redundancy purpose. In addition, the number of route reflectors should be sufficient to handle the total number of BGP peer connection in the network. The placement of route reflectors is critical to the design of a BGP RR network. Route reflectors should be placed in a hierarchical manner to minimize the number of BGP peer connection required between routers. In general, route reflectors should be placed at the core of the network with route reflector clients located at the edge. For larger networks, route reflector should also be placed outside of the data path and should only be used for route reflector functions and not as a data forwarding device. Please, if you like the content, hit the like button and subscribe. It will help me grow this channel. BGP route reflector design offers several benefits for large-scale networks by reducing the number of BGP connections required between routers. Route reflectors simplify network design and reduce the resources requirements. In addition, route reflectors improve network scalability by reducing the impact of adding new routers to the network. Overall, BGP route reflector design is an important consideration for any organization that operates a large-scale network and wishes to optimize the network performance and reliability. Here, in the design, we can see physical topology for wide area network with 7 routers. This is a small network, but for our purpose, it will help us understand the benefits of route reflector in iBGP network. In physical topology, we could see logical iBGP session. This shows that each router must be connected to every router on the network. That means that on a network with 7 routers, each router will have to maintain connection to another 6 routers. This doesn't sound like a lot in our topology, but just imagine how it would look if you would have 100 routers. Each router would have to have a 99 iBGP session, and in total it would be over 4,900 sessions for whole iBGP network. Also, adding and removing a device into the large iBGP network requires changing configuration on each device to add a new neighbor. On the other hand, if we have the same topology with 7 routers and we will elect 2 of the routers to be route reflectors, the number of sessions per device will rapidly decrease, as we can see in the schematics. Each client of the route reflector in our design would only maintain 2 iBGP sessions. Route reflectors would still peer with each router on the network. This hierarchical simplification of the flat iBGP network brings many benefits. For example, in a much larger network, adding and removing device is a much simpler process. Configuration on a client router is the same on every device through the network. There are only 2 neighbor statements for route reflectors. This setup makes adding and removing device a very simple process. I would highly recommend, if you're studying for CCNP or CCIE, to lab this setup to experience the benefits of simplified configuration. Please, and let me know in the comments below if you are using route reflectors or if you have migrated network from traditional flat design to route reflector setup. Thanks for watching, and I'll see you next time.